Hello, and today we are talking about the derivatives of exponential and logarithmic functions. Now, we have already discussed this one. We are just revisiting this one. This is the derivative of e to the x is simply e to the x. And at the bottom of the screen, we are also revisiting this one. The derivative of the natural log of x is 1 over x. Let's scroll down for a moment. And along with that, we have the chain rule, which is how we've actually been using these two derivatives. The derivative of e to the u is e to the u times the derivative of my inside, du dx. And the derivative of natural log of u is 1 over u times the derivative of the inside, du dx. Then we have one new derivative, and that one is right here. And that is when we have a number raised to an exponent, just like we had above with e raised to the x, that derivative is e to the x, except this one would be a constant, like maybe 3 raised to the x. Then the derivative of that is going to be 3 raised to the x times the natural log of 3. Same thing is going to happen, scrolling down again, when we have an a to the u. So that would be like 3 to the 5x. Then that derivative is going to be I keep saying 3 to the 5x times the natural log of 3, and then times the derivative of the inside, and that inside is 5. So we're going to go back up and look at that first example. So we have here in this first example something that we should recognize. We've been working with this, and we've been working with it with the chain rule. So this derivative, because it's an e raised to something, is going to be e raised to that something. And then, sorry, my something should be red, then times the derivative of the inside, that something, which is 2. And again, that's nothing new. So for the next one, I would like for you to try this one. So please pause the video here to complete this problem. Here is the solution, so please check your answer. If you have any problems, pause the video here. So again, I didn't actually write this down, but you do need to memorize this rule, and you need to memorize this one, which I didn't even discuss. But this is when we have logs of different bases. So now I don't have a natural log necessarily. I have a log to a different base, log base 3, log base 10, something different. And that derivative is this. And again, we'll be working with that with the chain rule. Moving on to the next one. Again, I would like for you to try this one. And then, but before you start, let's get calculus friendly, okay? So pause the video here and complete this problem. Here we have the solution. Again, it was written in calculus-friendly terms, and then the derivative is written below. So pause the video here if you have any issues. And moving on. So here we have that new kind with a different base other than e, and I'd like to start over here. So the base is a constant, and the exponent is a variable. And that's very different than the power rule. So if we look at what the power rule says, if I take the derivative of x cubed, I'm going to move my exponent down. I'm going to subtract 1 from my exponent. My new exponent is going to be 2, which is very different than 3 raised to the x. So the key is if your exponent has a variable, okay, an x, then you're dealing with this derivative. So please try and keep the 2 straight because they are different. So let's look at this one. So in this example, we have 8 raised to the x. So dy dx is going to be, again, the 8 raised to the x, and then I need to multiply by the natural log of the base, which is 8. So there it is. That is the derivative of 8 raised to the x. So on that note, I would like for you to try this one. So please pause the video here to complete the U try. I'm going to scroll just a little bit, and here's the answer to that U try. Now, if you made a mistake, please pause the video here to please fix that. Now, the next thing we want to talk about is, well, do I simplify this? Do I rewrite it? Do I do anything like that? And the answer is no, please don't. Most of these answers aren't going to simplify a lot anyway, but if you simplify and make a mistake, you've made your correct work incorrect, and we do not want you to do that. So let's look at this next example. Dy dx for y is equal to 3 raised to the cotangent of x. So first I'm going to rewrite this in my colors. So my outside function is 3 raised to something, and that inside function is cotangent of x. So we're going to find our derivative. So dy dx is going to be 3 raised to that same thing times my natural log of 3, so that finishes off that derivative of 3 raised to something. Then I need to multiply by the derivative of the inside. Derivative of cotangent is negative cosecant squared of x. And again, we don't want to do anything to it, we just leave it alone. Next one. And here we are at the next example. And the first thing I'm going to redo is write in my colors. I have 2 raised to the 5x. So to find my derivative again, dy dx is going to be 2 raised to the 5x. And then to finish off that part of the derivative, the outside, I'll multiply by the natural log of 2. Then I multiply by the derivative of the inside, which is 5. Now, a lot of people, and this is written over here in this circle, what a lot of people try and do here is they rewrite the 5 in front times 2 raised to the 5x times natural log 2, and then they decide that this is 10 raised to the 5x, which is incorrect. The only thing that is raised to the 5x is 2. That's it. So if you multiply by the 5, it's simply 5 times that thing. You may not go here. So that is another example of please don't simplify. Leave your answer right here. That answer is wonderful, and people who simplify generally make mistakes, and we do not want you to do that. So moving on to the next page. There's 2 ways that we can do this, and I'm going to go ahead and do it the original way. So I would probably rewrite this as the outside function is natural log, the inside function is x squared. And we know this derivative, we knew it before, and that is dy dx is going to be 1 over whatever I was taking the natural log of, in this case, that's x squared. And then I take the derivative of the inside and I multiply, so I'd multiply by 2x. And I can leave that alone, or I could simplify it. If I were to simplify this, it would end up being 2 over x. Now, the other thing that we could have done is we could have used our log properties first. And if you look at this box right here, we could, starting with our function, there is a property. I'm going to scroll to where the properties are. They're on the next page. I'm going to scroll down now because they're near the bottom. We do have, the rule that we're looking at is this one. And if I have the natural log of something raised to an exponent, I can bring that exponent down in front times the natural log of y. That's not taking a derivative. Okay, it is not taking a derivative. It's just rewriting. okay? A lot of people think once they've used the log rule, they've actually found a derivative. This is not a derivative. Back to the problem we were on. So using that rule, it can be rewritten here as 2 times the natural log of x, which is a very, very simple derivative. My constant stays, and the derivative of natural log of x is 1 over x. So again, it doesn't matter which way you do it, whatever you're more comfortable with, but you get the simplified answer, which again on the multiple choice section, much easier that way than you do the original way. So moving on, I would like for you to try, not that one, I would like you to try this one. And again, you can rewrite it if you would like, or you can leave it alone. Please pause the video here to complete this U-try. Here are the 2 solutions. One way I did, if you had just left it as it was, and the other way I did it is if you first rewrote with the log rules. And again, it doesn't matter which way you do it, but if you made a mistake, please pause the video here to correct. And next, moving on to this last style of derivative that we haven't talked about yet. So first of all, what was that rule? Go back to the front, we can find it, and I'm going to write it as the chain rule version, and that's d dx of log base a of u is going to be 1 over u times the natural log of a times the derivative of the inside, du dx. So I'm going to rewrite with my colors so I know what my inside and my outside is. My outside is the log base 4, and my inside is x squared. So taking this derivative is going to be 1 over u, which my u is x squared, times the natural log of a, so the natural log of 4, and again that's part of my derivative of my outside. And then I'm going to multiply by the derivative of the inside, which is 2x. And again, I can leave it just as it is. Moving on to the next page. Right now, what I would like for you to do is to read this. Please pause the video here to read that statement. So what we're going to do now is we're going to rewrite this calculus friendly. And I will again use my colors. My outside is log base 10 of my inside is x plus 1 to the 1/2. So taking my derivative, using the same rule I just used, that's 1 over my u, which I can rewrite either calculus friendly or the original way, times the natural log of a, and the natural log of a, a is my 10, then times the derivative of my inside, which is 1/2 x plus 1 raised to the negative 1/2. And we can, again, leave that alone. Scrolling down, using our log properties. Again, these properties are for rewriting only. They are not for writing derivatives. But you need to memorize these. And you need to memorize these because although it does make your life easier, sometimes you will be given multiple choice questions by us where you will be forced to know these rules. Knowledge is not going to fit right there, sorry. So you do need to know them. So again, you start seeing some multiple choice questions. On to the next page. We did have a problem from the product rule practice. It was a true-false question. Is the derivative of 10 raised to the x the same as x times 10 raised to the x minus 1? And that is a false because the variable is the exponent. So you have to use that other rule. So this would be y prime would be 10 raised to the x times natural log of 10. Now, there are 10 problems listed below where you're asked to find each derivative. This is completely up to you. You're welcome to try and practice these based on the video that you've just watched, or you can work on those in class. And again, it's completely up to you. But what I'm going to do is I'm going to put the answers up. So if you do want to check them, go ahead and pause the video here to complete the derivatives, and then play the video so you can see the answers. So pause the video here, please. Here are the answers to problems 1 through 6. Please pause the video here to check these answers. Here are the answers to 7 through 10. Please pause the video here to check these answers. And that is the end of the video. Have a wonderful evening.